Let us learn about the seventh property in this particular class. So this is the seventh property of skew-symmetric matrices. Now what does the property say? If A and B are two symmetric matrices, okay? If A and B are two symmetric matrices of same order, obviously they must be of the same order, because only then this expression will be defined. This expression can be defined only if A and B have the same order, okay? So A and B are two symmetric matrices of same order, then AB minus BA is a skew-symmetric matrix. AB minus BA is a skew-symmetric matrix. This is what we need to prove. This is what we have to prove. Now, the first sentence says that A and B are two symmetric matrices. So let us write A and B are two symmetric matrices. Now, as A and B are two symmetric matrices, so A transpose will be equal to A and B transpose will be equal to B, because A and B are symmetric, and by definition of symmetric matrix, A transpose is equal to A, B transpose is equal to B. How? By definition of symmetric matrices. By definition of symmetric matrices, A transpose will be equal to A and B transpose will be equal to B by definition of symmetric matrices. Let us assume that this is equation 1. Let us assume that this is equation number 1. Okay. Now you need to show that this is skew symmetric. You need to show that this is skew symmetric. So let us take its transpose. Let us take its transpose. So AB minus BA, AB minus BA, AB minus BA complete transpose, AB minus BA complete transpose is equal to AB complete transpose minus BA complete transpose. How is this happening? This is from the property. This is from the property that A minus B, okay, A minus B transpose is equal to what? A transpose minus B transpose So from this property, from this particular property, that A minus B complete transpose is equal to A transpose minus B transpose, okay, A minus B complete transpose is equal to A transpose minus B transpose. By this particular property we will expand this. So AB minus BA complete transpose is equal to AB complete transpose minus BA complete transpose. This is the thing. Now we already know one property. From this step to this step, while going from this step to this particular step, from this step to this step, there is one property that CD complete transpose is equal to D transpose C transpose. Okay, so by using this particular property, let us apply this property to this. AB complete transpose is equal to B transpose A transpose by this property, which we had already learned. Okay, and BA complete transpose is equal to A transpose B transpose, Okay, AB complete transpose is B transpose A transpose, and BA complete transpose is A transpose B transpose. Okay, got it? AB complete transpose is B transpose A transpose, and BA complete transpose is A transpose B transpose. Now B transpose is equal to B, so we have written B. A transpose is equal to A, so in the place of A transpose we have written A. Again in the place of A transpose we have written A from this, and again in the place of B transpose we have written B. In the place of B transpose we have written B by equation 1, by this particular equation 1. Now let us take out the minus sign common. From here. So when you take the minus sign common, AB minus BA is the expression which you get. Okay, so minus AB will become plus, and plus BA minus AB will become plus, and plus BA will become minus BA. Minus AB will become plus AB. Minus AB will become plus AB, and plus BA will become minus BA when minus sign is taken common. Now have a look at this particular thing, at this particular expression. That this particular thing comes out to be equal to minus of this matrix. Okay, this matrix transpose is equal to minus of the same matrix. So when we are taking the transpose, it comes out to be minus of that matrix. It means that AB minus BA is skew symmetric matrix. How is it skew symmetric matrix? Because it is satisfying this particular condition. Okay, it is satisfying this condition that AB minus BA complete transpose is equal to minus of AB minus BA. So AB minus BA is the skew symmetric matrix. You can clearly see that AB minus BA is skew symmetric matrix. From here you can clearly see this. This is from the definition. By definition, AB minus BA is skew symmetric matrix. Okay, now there comes the property number 8, which we will learn in the next class. We will learn property number 8 in the next class. Okay, till then, like, subscribe and share. Thank you very much.